Hello everyone, welcome to today's class. In this lecture we are going to discuss the topic of definite integral. We'll be starting with the basics. Okay, so let's understand first of all the basic difference between indefinite and definite now. So suppose you integrate a function fx dx. Okay, that gives you some gx. Okay, so you integrate a function, you get another function. Fine, that's your indefinite integral. But if you integrate a function fx and you get a limit assigned to it from a to b, what is the meaning of that? If you want to understand the physical meaning comes in the application of integration, but let's understand the basic here too. Suppose this is your function, okay, fx. So suppose you are integrating from point A to point B. So basically this area will be your integration fx dx a to b. Okay, this area, that is the meaning of definite, physical meaning of definite integral. Now that you have understood that, the questions will be same. Okay, so starting we are going to just normally use the integration what we have learned so far and just put the limits, how to deal with limits. So let's see the questions. Okay, let's start with a simple example, starting with x square integration. So integration of x square is x cubed by, integration of x square is x cubed by 3, and then you have to put the limit of 2 to 3 on this expression. So what you do is you put the limit of 2 to 3 basically by putting the value in x. So we are putting the limit also in 2 to 3 inside x, not this 3, so let it be outside. So 1 by 3. How do you solve this? After the integration, it will be represented in a square bracket and limits will be written on the right. This is called lower limit, this is called the upper limit. You first have to put the value of upper limit, that is 3 cube minus then lower limit 2 cube, always upper limit minus lower limit. So this is 1 by 3, 27 minus 8, that's 19 by 3. Okay, simple enough. Okay, now next question. We'll use the same idea. The task is to actually integrate it as an indefinite integral and then put the limit. So let's integrate for the time being. So this integration, clearly the weirdest looking part. Okay, this is the weirdest looking part, that will be your t. Okay, so if you differentiate this, so 30 minus x raised to power 3 by 2 is t. So differentiation of this is minus 3 by 2 x raised to power 1 by 2 is equal to, into dx is equal to dt. Okay, now in order to substitute this, we have this root x, that's basically same thing as x raised to power 1 by 2. All we need is minus 3 by 2, so multiply and divide. So put minus 3 by 2 here Then in order to cancel this, put minus 2 by 3 outside. So this integration becomes minus 2 by 3. Numerator becomes dt, denominator becomes t, na? So t square. So what is the integration of t square? Means 1 upon t square. That will be minus 1 by t. Okay. I'm not putting c. Why? Because c, we are doing definite integral. In definite integral, we don't add c. Even if you want to add c, if effectively when you solve upper limit minus lower limit, the c will get cancelled. So remember that if we are doing definite integral, no need to put c. Okay. Now let's replace the action. Minus 2 by, it will become plus 2 by 3 into 1 upon 30 minus x raised to power 3 by 2 complete raised to power square. And we have to put the limit. What was the limit? 4 to 9. Okay. So 2 by 3 upper limit, if we put, so 9, so 1 upon 30 minus 9 raised to power 3 by 2. If you solve this, 9 is 3 square, na? So 3 square raised to power 3 by 2. 2 cancel, 3 cubed, so 27. This is upper limit, minus lower limit is 1 minus 30 minus 4. 4 is again 2 square, so 2 square power 3 by 2. That minus 8. Okay. 2 by 3, this becomes 1 by 3 minus 1 by 22. You can take the LCM and solve this and get the value. Okay. Uh, 2 by 3, this becomes 11, 3, 33. 11 minus 66. 22 minus this one becomes 3. So 2 by 3 into 18 by 66. Nice. Sorry, not 18, 19 now. And still you can cancel this. So 19 by 99. Okay. The point is, for solving a standard definite integral, just solve the question as an indefinite integral, and finally once you are able to get the final answer, don't use c, just use upper limit minus lower limit. Okay. Okay. So I'm not going to discuss so many questions based on this practice. The next concept I want to teach is how to change limits. Okay. Let's take few questions on that. All right. Now see, again same idea. What you can do is normally integrate. Okay. And then put upper limit minus lower limit. Slightly different approach we are going to use. We are doing substitution because the weirdest looking thing is this one, and clearly the differentiation of x raised to power 5, if we call this as t, 5x raised to power 4 dx is your dt. Okay, so let x raised to power 5 plus 1 as t, then 5x raised to power 4 dx is dt. Now I want to change the limit also. I want to do this question itself in t, and I don't want to go back to the x. Okay, so this becomes square root t dt If only I know what is the limit now. I cannot use minus 1 and 1 because these are the upper limit and lower limit of x, not t. So I need to convert it. The point is I have to create, when x is minus 1, I have to get the value of t, and when x is 1, I have to get the value of t accordingly. So if I put this value x equal to 1 here and x equal to minus 1 and 1 here, I'll get the value of t in this expression. So putting minus 1 here, minus 1 raised to power 5 plus 1, so this becomes 0. If I put 1, then 1 raised to power 5 plus 1, that's 2. So basically this integration limit changes from minus 1 to 1. That was for x, but now since x is being replaced by t, I want a new limit also, because I want to directly solve this in t. I don't want to go back to the x part, so I have to change the limit. So this limit becomes 0, lower limit becomes 0, upper limit becomes 2. And now I don't have to get back to the question in form of x and then put the limits. Directly solve this. What is the integration of root t? That's t raised to power 3 by 2 into 2 by 3, and put the limits of 0 to 2 in this. So directly you get 2 by 3, and this becomes 2 raised to power 3 by 2 minus upper limit minus lower limit 0 raised to power 3 by 2. So that is 2 by 3, 2 raised to power 3 by 2. That's your answer. Okay. You can further simplify if you want to. Suppose the answer is not given like this. What they can do is, or you can write this as, what is 2 raised to power 3 raised to power, basically 3 by 2, you can rewrite this as 2 raised to power 3 raised to power 1 by 2, which is 8 raised to power 1 by 2, which is root 8, which is again 2 root 2. So you can rewrite this answer as 2 by 3 into 2 root 2. That becomes 4 by 3 root 2, another possible answer. Depends how the questions asked. Okay. But the most simplified answer, of course, is this one. That can further be simplified. So let's erase this as a final answer. All right. So now that we have seen one question, how to change the limit, that was the main idea. Same thing we'll do with the other questions also. Then we'll look for a few questions also accordingly. Okay. Let's look at this question now. Again, I think from integration point of view, if you have gone through all the notes, this should be a piece of cake. Tan inverse should be t. This whole thing, tan inverse differentiation is 1 upon 1 plus x squared, dx becomes dt. That's not the problem. The problem is changing the limit. Of course, this integration becomes t dt, which is t squared by 2. But I have to decide the limits. So since we have let tan inverse x as t, so when this lower, let's change the lower limit first of all. For lower limit, when x is 0, if I put x as 0, what do I get? Tan inverse, t is tan inverse 0. What is tan inverse 0? 0. And when x is 1, then t is tan inverse 1, which is pi by 4. So this integration limit becomes, lower limit become, this was lower limit, this was upper limit. Okay, so this becomes 0 to pi by 4. I think that makes it very simple. Now 0 to pi by 4. I don't have to get back to the x and then put this limit. I can directly solve this. So pi square by what I can do is I can take 1 by 2 outside, then pi square by 16 minus 0 square by 0 square, basically 2 I have already taken outside, so that is pi square by 32. Okay, that's your answer. Here also we changed it now, so this was the lower limit first, then upper limit we converted. Okay, we're done with this. Now let's look at a few questions. Alright, for this question, clearly again, if you look at this is x square plus 1. Of course, numerator and denominator. Denominator is typical. So t, x square plus 1 differentiation is 2x. We don't have 2x here. Okay, 2x dx. So multiply this by 2, then also divide by 2. So then this whole numerator part becomes your dt. Okay. So the question will look like this: 1 by 2 integration some limit that we have to decide dt by t. Okay. Now all you have to do is convert it. We have taken x square plus 1 as t. So for lower limit, when x is 0, okay, 0 is the lower limit, your t is 0 square plus 1, so basically 1. So for upper limit, when x is 1, t is equal to 1 square plus 1, that's 2. So basically your integration limit changes from 0 to 1 to 1 to 2. Okay. That's 1 by 2. 1 by t integration is log t. Okay, and then as basically log mod t, but see, this time we know what's our t. T is a positive quantity, so I don't have to put a mod here. Okay, if I want I can still, but won't make any difference. Now you have to solve 1 by 2 log 2 minus log 1. What is log 1? Log 1 is 0, so this becomes 1 by 2 log 2, and that's the answer of this question. Okay. One second. Okay, next question. Zero to pi by 2 square root sine phi cos power 5 phi d phi. Okay. So for this question, clearly square root sine is there, so I think inside the square root, let that be t. Okay. Let sine phi is equal to t. Okay. Let's write it here. Substitution I'll write here. Let sine phi equal to t. Okay. Then cos phi d phi is equal to dt. So we need one cos with d phi. So what do? Let's keep the limit same. Let's write down the same question, sine phi. Just break down cos as cos raised to power 4, which is cos square phi whole square into cos phi d phi. Now this thing is your dt, all set. So this is 0 to pi by 2. Let's leave the limit. This is dt. Sine phi was t, so root t. Cos square is 1 minus sine square, means 1 minus t square whole square. Okay, and the limit is, we have to decide the limit, we have to change the limit, otherwise we'll have to put t as sine phi and then we can solve. So let's change it. Okay, lower limit when x is 0, your t is, what is sine 0? Sorry, not x, this time we have phi na. So when phi is 0, then t is sine 0 is 0. Similarly, upper limit when phi equal to pi by 2, t is equal to, what is sine pi by 2? That's 1. So integration limits are, lower limit is 0, upper limit is 1. We have converted the new limits. Rest everything is same. So now integrate. Multiply this. Before multiplying, I think 0 to 1 root t. This is 1 plus t raised to power 4 minus t raised to power 2t square. No, a square plus b square minus 2ab. Now we'll have to multiply 0 to 1. The expression will look weird, but once you put the limit 0 and 1, they are very easy numbers to solve. So you'll get a average answer. Okay. So root t means t raised to power 1 by 2 plus 1 by 2 plus 4, 9 by 2. Okay. Minus 2 t raised to power 3 by 3. No, sorry. I have to multiply now first. 1 by 2 plus 2 by 2. So 5 by 2. 2 t raised to power 5 by 2 dt. Now let's integrate. This becomes t raised to power 3 by 2. Here 2 by 3. Okay. Plus this becomes t raised to power 9 by 2 plus 1, 11 by 2. Okay. So 11 by 2, 2 by 11 plus, not plus, minus 2 into t raised to power 7 by 2 into 2 by 7. Okay. Now what you can do is, I told you that for solving the limits you don't have to put in the whole expression 0 and 1. What you can do is solve them separately, and especially on the variable part, not the constant part. 0 and 1, 0 and 1, 0 to 1. Okay. So this becomes 2 by 3. Upper limit is 1, so 1 raised to power anything is 1. 0 raised to power anything is 0. Okay, so this becomes simply 1 minus 0. Same here also, 2 by 11, again 1 minus 0. This is minus 4 by 7, again 1 minus 0. So it is 2 by 3 plus 2 by 11 minus 4 by 7. We can take the LCM, all prime. 77 into 3. 231. Okay, so this becomes 77 into 2, 140, 154 plus 14, 21 into 2, 42 minus 33 into 12, 132. Let's make it 4 minus 4 plus 2, 6 minus 2. Minus 90. So minus 90, and this will 64. So 64 by 231, it's coming. Anyway, calculation part, pretty much I'm sure you are better, so you can do that easily. The only struggle is mostly with changing the limit and getting the integration correct. That's the main part. Okay. Look at this question. Now this question can be done using substitution, but there's a question of inverse also. You should be comfortable in solving this as an inverse question, even if the integration was suppose not given, and I ask you what should be the substitution here to solve this. You should know this from the inverse trigo. This is substitution by tan. Okay, so let x is some tan theta, then this your dx is equal to sec square theta d theta. Okay, let's put it here. Let's replace this dx, then this expression, of course, so that expression will solve, but limit also we have to decide. So your lower limit when x is 0, so basically your theta is tan inverse x. So when x is 0, so theta is tan inverse 0, that's 0. And upper limit when x is equal to 1, so your theta is equal to tan inverse 1, that's pi by 4. So basically your integration is 0 to pi by 4 sine inverse 2x is 2 tan theta upon 1 plus tan square theta. You should know what is this. Again, trigo. Dx is sec square theta. You need more space. 1 second. Sec square theta d theta. So this becomes sine 2 theta, and sine inverse and sine it cancels. Okay, I have to change the limit. Oh, I have changed it. Okay, so this becomes 0 to pi by 4. This becomes 2 tan theta 1 plus tan square, na? So this becomes only sine 2 theta, that means 2 theta into sec square theta d theta. Okay, all right. Now this is like theta 2 is constant, 2 is not a problem, 0 to pi by 4. You have to focus on theta sec square theta. So pi by 4 theta sec square theta d theta. It is kind of like x sin x, x tan x. So whenever you have two different kind of functions, what do we use? By parts. So by parts you'll have uv, okay, first function, second function. So for that we use isolate. Okay, so algebraic expression is first, then trigo. So this is your first function, this is your second function. Okay. So this becomes 2 times first function as it is. Okay. Integration of second function. So first function as it is, integration of sec square theta. I'm not writing limit, we'll write the limit in the end, minus integration of sec square, differentiation of theta, and then integrate with respect to dt. This complete thing is being multiplied by 2. So 2 into theta sec square theta is tan theta integration. Okay, d theta, of course, whenever integration is there, of course it's with respect to d theta. Okay. Minus integration of sec is, this is tan theta, and theta differentiation is 1. Okay. So 2 times theta tan theta minus, what is the integration of tan? Minus log cos mod x plus c. As such, again we are dealing in first quadrant, 0 to pi by 4, so basically we don't have to put mod, we can write only cos x plus c. So not even c now, we are solving. Last step, now let's put the limits, bad habit of writing c. 0 to pi by 4. Okay. Put the limits now, that's it. So what we'll do is we can solve this directly also, or in 2 parts also. What we can do is we can put limit like this also, I told you. This was not log cos x, this was log tan, this was in terms of theta. Okay. 0 to pi by 4, 0 to pi by 4. Let's solve them separately, it'll be easier. So you can solve in one go together also, it's not a problem. So basically pi by 4, tan pi by 4 is 1, minus lower limit is, you put 0, 0 into anything is 0, so 0. This is first part. Okay, second part, plus log cos theta, so log cos pi by 4 is 1 by root 2 upper limit, minus lower limit is log cos 0, so log cos 0 is 1. And what is log 1? Always 0. So basically this becomes pi by 2, and what you can do, plus 2 log, basically see 2 is being multiplied, so I'm multiplying, this expression is only pi by 4, this is only expression log 1 by root 2, so pi by 2 log 1 by root 2. Okay. And what you can do is raise the power, so this is pi by 2, this is plus, take this in the power, so that will be log 1 by 2, and still if you want to manipulate, you can write down as this pi by 2 minus log 2. Basically log 1 by 2 is log 2 raised to power minus 1, and minus 1 can come down. Okay. Last 2 steps pretty much both can be the answers. Okay. Alright, we're done with this now. I think you get the whole idea. Basically pretty much the integration is same, it's just that if you are using substitution, you should be comfortable by this method of changing the limits. Not all questions will be based on this. Suppose you are comfortable in, no, I don't want to use this, I'll replace the value of t as x and then put the limits, fine. But you should get to know how to change the limits, because certain questions are theoretical in nature, or will not have a limits as 0 to 1, or it will have some a to b or some kind of limit. Okay, so in those kinds of question, usually this changing of limit helps a lot. Okay. Alright. Fine, I think that's it. We'll continue in the next class. This is it for basic of your definite integral. We have seen basic of definite integral, we have seen the changing limit part of it. Okay. Okay, that's it for this class. See you in the next class. Good day everyone. Bye.